Hello, welcome to this projectiles problem which I'm going to walk through. It's from Physics and Maths Tutor. I've just chosen a nice elevated projection problem to walk through. This is a particle P is projected from a point A with speed u meters per second at an angle of elevation theta there, where cosine theta is 4/5. So I'm just going to stop there and we're going to work out what the initial velocities are in terms of the components. I'm going to, in this case, say down is positive. It doesn't really matter. All that matters is that you're consistent. So if I do a little triangle there, I'm going to say theta, cosine is 4/5. That means that's got to be 3, the Pythagorean triple. Now this means, well, I know cos theta is 4/5, sine theta is 3/5, and I'm going to use that to say initially horizontally this is 4/5 u, and because that's going upwards and I've said downwards is negative, that's negative 3/5 u. Okay, let's continue. So the point B, you've got a point B on horizontal ground and it's vertically below A, and AB is 45 meters. After projection, P moves freely under gravity, normal projectile. It goes through C there, and that's 30 meters high, so that, crucially, that distance there, vertical distance, is 15 meters. We'll be using that. And it strikes the ground there at D. Okay, right, we're told this. We're told that the speed is 24.5 meters per second at C. So we've got to use that to prove that this initial speed, the magnitude of the speed, is 17.5. First of all, let's work out the vertical velocity at this point. And how we do that is this. We use suvat vertically. So I say vertically, I'm going to say S is 15. Down is positive displacement. U is negative 3/5 u. So that's uy. Vy, well, we don't know, so I'm just going to call it Vy. Acceleration is 9.8, of course. T is not really required here. So what do I do here? Well, I'm going to use Vy squared equals Uy squared plus 2ASY. So let's put this all together. My Vy squared is going to be 9/25. It's negative 3/5 u squared, so it becomes positive u squared plus 2as. Well, 2 times 9.8 times the 15 meters gives me 294. So there we know Vy at this point is this, 9/25 u squared plus 294. Well, what about Vx at that point? Well, Vx is going to equal, I know Vx is always 4/5 u, always. It's no acceleration horizontally with a model of a projectile. So let's square that, 16/25 u squared. Well, why have I got Vx squared, the velocity horizontally squared and the velocity vertically squared? Because Pythagoras will tell us if I square this 24.5, if I do 24.5 squared, it will equal the horizontal velocity squared, which is 16/25 u squared, plus the vertical velocity squared, which is 9/25 u squared plus 294. So that speed there is 24.5. Well, this is nice because I add those together, it gives me 1 u squared. And what also is nice is if I can move that over, do 24.5 squared, take away 294, and I get 306.25. I did that calculation earlier, to be honest. I square root that, and I've got 17.5 as required. So it's a case of working out the vertical velocity at C, knowing the horizontal velocity is constant, and if I square those two, add them together, I get the speed. Now the size of the angle, it's not too tricky this, so it's going to be going that way. We're making an angle there, it's going on its downward trajectory, that I'll call it alpha. Well, I know that the horizontal velocity now is, well, what is that? Horizontally, it's going to be 4/5 times 17.5, so that's going to be 14. So it's 14, and the magnitude, which is the hypotenuse, would be 24.5. So that angle there would be arc cos of 14 over 24.5, and to the nearest degree, which I'm going to give it to, is 55 degrees. There we go. Right, we've got to find the distance BD. What I'm going to do is I know enough about the vertical distance to find the time. S equals UT plus a half AT squared. Well, I know that S distance in the positive direction is 45. I should have said a displacement. Now U, the initial vertical velocity, is negative 3/5 times 17.5. So it's going, that is negative 3/5 times 17.5, which gives me negative 10.5. So negative 10.5 T plus a half A, a half times gravity, taking gravity as 9.8, a half of it is 4.9 T squared. Well, we rearrange that and we get a lovely quadratic. So 0 is 4.9 T squared minus 10.5 T minus the 45. Well, there's lots of ways to solve a quadratic. I'm not too interested in the methods at the moment, I just want an answer. So I stuck that in a calculator and got 4.29 seconds. I also got negative 2.14. Don't want that, do I? That's negative. What that really means is, if the projectile started to go backwards, it would hit, I went back in time and somehow could go through the cliff, it would take 2.14 seconds to get to there. That's what it means. But quadratics don't quite understand you working in real life, or almost real life, and we're just going forwards, so we want that 4.29. So my final job is to find the distance. So, or the displacement, I'm going to say the distance BD. Distance BD is going to be horizontal velocity times the time. How fast is it going horizontally? Well, it's going 14 horizontally, and it's travelling horizontally for 4.29 seconds, and that gives me 59.92, but let's make that to the nearest metre, 60 metres. Very common theme there. I use the vertical case to find the time of flight. How long does it take to hit the ground? I know I'm looking for when it's gone 45 metres displacement in that direction. That can give me the time. Be careful, get a quadratic 2 times. Then I just know horizontal is constant, isn't it? Horizontal velocity is constant. Horizontal velocity times time. Some really good questions from this. Really good question. So, hope that was clear. Thank you very much.